Okay, so for, again, this section we're going to deal with factor theorems and remainder theorems. So with this warm-up, what do we think? Is 5 a factor of 45? Okay, it is. Why? Okay, so you're going 5 into 45. Goes 9 times. Okay, and if we multiply, what happens with the remainder? 0. So it went in evenly. Okay, it goes in 9 times. But what if we tried 6 into 45? Not evenly, right? It goes in 7 times, but we have a remainder. Okay, it did not go in evenly, so it would be like 6 and 3/6, or I'm sorry, 7 and 3/6, or 7 and 1/2. So it doesn't go in evenly, so that means it's not a factor. Okay, so to be a factor, something has to go into it evenly. No remainder. Okay, the remainder has to be 0. And that's what we're going to talk about in this section with polynomials and everything. We're going to say, is something a factor of another polynomial? And we're going to check it just like we did here. We're going to make sure that the remainder is 0. Okay, and that's going to like be our proof that it does go into it evenly. Okay, 6 did not go into it evenly. Not a factor. Okay, so any question on that? It's just kind of a little lead-in introduction. Okay, all right, so here's our new stuff. Okay, and keep in mind what we just did. Okay, let's show that x minus 3 is a factor of that big thing, and then we'll find the remaining factors. Okay, so we're going to do this just like the warm-up. I'm going to see if I take this big expression here, this big polynomial, okay, x cubed plus 4x squared minus 15x minus 8. Okay, just like we did in the warm-up, we divided it by the thing that we want to show as a factor. Oh, thank you. And divide it by the x minus 3. Okay, how will we know that it's a factor? If the remainder is 0. Okay, so we want the remainder to be 0. That says that it goes into it evenly. So we need to do this division problem. Okay, and you guys have a couple methods. You have long division, which some people just kind of stuck with and like doing. I would recommend doing synthetic. Okay, we're going to use synthetic with another application today too. So if you don't remember synthetic, now's the time to refresh on that. So how do we set up synthetic? Positive 3. Okay, since we're dividing by x minus 3, we'll put a positive 3. And then we do the coefficients of the big one. So in order, it's 1x cubed, 4x squared, negative 15x to the first, and then negative 18. All right, and then we have our process. Bring down the 1. And then we're going to multiply the 1 by the 3 in the box. So 1 times 3 is 3. If we add the 4 and the 3, we get a 7. And now we just repeat the process again. The 7 times the 3 is 21. Negative 15 plus 21 is 6. 6 times your 3 is 18. And we did get the remainder of 0. Okay, so that does prove then that x minus 3 is a factor, because it went into it evenly. Okay, and that's all we wanted to do so far. Okay, we're going to do some more in a second here. But that's step 1, show that it's a factor. Okay, to show that, you do this work, you show me the remainder 0. Okay, so part 1's done. Now we need to find the remaining factors. So x minus 3 is one of them. What are the rest of them? Okay, so any thoughts on how to do that? Not necessarily. Okay, would you guys agree that the original big thing that we started with, okay, that big thing, we just divided it by x minus 3, right? And then what's the other factor here? Do we remember how this plays a role? Yeah, that's the other factor there. X squared. Okay, I'm taking the coefficients from here, right? Remember, I decreased the exponent by 1. It's x squared, then it's x. Okay, so we really took the big polynomial, we divided it by something, and we got the other factor. So the x minus 3 times this answer that we had equals the big one we started with. Okay, that's just what a division problem is, right? And now can we factor anything else? Of those two factors that we have there, can this guy be factored? A little bit farther. Can we break it down more? Like old stuff. X squared plus 7x plus 6. Old stuff. It can be done. X plus 6, x plus 1, right? So this x minus 3 is still just the same. But the stuff I highlighted, like the old quadratic stuff, factors of 6 that add up to 7. So you want to break them down as far as you can. And now it's factored all the way. So this is like the final answer. It's all of the factors broken down as far as they can go. Okay. Okay. Okay, so let's try a similar one like that. Okay, same process. First start out by doing the division, and then we'll worry about the remaining factors afterwards. Okay, hopefully we notice that there is no x squared term, so after the 2, before the negative 8, we have to put in a plus 0 for the x squared. Okay, make sure you have that 0 in when you do your synthetic. Okay, so let's set up the synthetic. So again, we're dividing by x plus 2, so we're going to use a negative 2. Okay, because anytime you're doing a division, you always just go by like the opposite of what the factor is. Okay. And then the coefficients, I had 1x to the 4th, right? 2x to the 3rds. Here's my 0x squareds. My negative 8x to the 1st. And my negative 16. All right, and then we do the same process. Bring the first one down. And we're going to multiply. So 1 times the negative 2 is negative 2. Add those together, we get a 0. Okay, 0 times the negative 2. Give me another 0. 0 plus 0. Okay, another 0 times negative 2 is still 0. Okay, that's negative 8. And then the negative 8 times negative 2 is positive 16. So we got a remainder of 0. So that shows that it is a factor. So x plus 2 is a factor because it went in evenly. Okay, so that's step 1. So x plus 2 is one of the factors of this big thing. Okay, the other ones will come from the answer to our division problem. Okay, and what is that answer? 1x cubed plus 0x squared plus 0x minus 8. So it's really just x cubed minus 8, isn't it? That's what this answer is. Okay, because remember the exponent always starts 1 less than the original. We started as a 4th degree. Right, so when we divide something out, we're always going to be 1 less than that. So we're starting out x. This is my x cubed. There's no x squareds. There's no x's. And there's just a regular minus 8. Okay, now that's the thing we need to try and factor farther if possible. Yeah, this is the difference of cubes. This is from last section. So we need to factor that out. So remember, if it's just two terms and they're both perfect cubes, this is x to the third minus 2 to the third. Okay, we had that formula from last section. You might need to look that up. The way to factor this is, remember, the a minus b. So this is like your a and your b. Okay, so how does it work? A minus b, so x minus 2, and then it's always a squared, and it's all, this one's plus ab, 2x, right? ab, 2x, plus b squared, 2 squared, 4. Okay, so that's the perfect cube stuff. Again, look that over. Can we go any farther? Can the second piece, that quadratic, be broken down any more? This. What do you want to try? We need factors of 4 that add up to 2. Yeah, I don't think so. It's probably decimals or something, right? It's nothing that we can factor. So we would just leave it like that. That's the other two factors. X minus 2 is one of them, and x squared plus 2x plus 4, those are the other factors. Okay, so when it says find all the other ones, there they are. So it was the original x plus 2 that we knew from the very first step, and then these other two. Okay. Okay, then the last thing in this section is called synthetic substitution, but I'm going to have you guys start by doing this without knowing the new method. This is something we should know how to do from a long time ago. Like, how could we find f of 3? Yeah, this is just saying substitute 3 in for x, right? F of 3 means plug 3 in for x and then simplify. And it's perfectly fine to do it this way, so let's do it. Let's plug in 3 for x. So 3 to the third minus 2 times 3 squared minus 3 plus 1. So I'm just plugging in 3 for each of these x's. Okay, that's all that means to do, right? And with the calculator or in your head, we should be able to simplify that to one number. Okay, and we get a 7. Okay, it should equal 7. Okay, just use a calculator, throw it in parentheses, be careful. That should equal 7. Okay, so what that's telling us, okay, on this graph, if we graphed this thing, when x is 3, the y value would be 7. That's all it's really telling us. Okay, nothing crazy there, right? 7. So if you do step by step, like, so 3 to the third power is what? 27. Minus 2 times 3 squared, which is 9. And then just follow the order of operations. You should get... Oh, no. Yeah, it's order of operations, right? So 27 minus 18. All right, that should get you your 7, okay? So now here's another way to do this, to avoid that kind of issue. Okay, if you don't, sometimes they get big numbers and they're, a little messier to do. This process called synthetic substitution will do the same thing we just did. Okay, and it's called synthetic substitution because it looks just like synthetic division. Except the only difference, and the thing you got to be careful with, if we want to find f of 3, we actually use 3. We don't use negative 3. We don't use the opposite like we do when we divide usually, because this is not that exact same thing. So we use 3 in the box, and then we do the synthetic process exactly the same. The exact same. Coefficients are 1. Okay, so I'm looking up here. 1, negative 2, negative 1, and 1. And the process is identical. All right, so let's do our steps. Bring the 1 down and then multiply. Negative 2 and 3 is 1. 1 times 3 is 3. Right, the negative 1 plus 3 is 2. The 2 times 3 is, and the 1 plus 6 gets us, okay, magically the same number we got before. The remainder will be the answer. Okay, so that's just an option instead of plugging it in. The synthetic process will work. Okay, so whatever you want to plug in for x goes right here, and the remainder will be the answer. Okay. Yep, exactly, yep. See, just like it was up top, right? So f of 3 equals 7. Okay, and sometimes it's easier to do that, sometimes it's easier just to do it the way we did up here, but it's just a process I want to show you, and so you know the name of it when you see it in pre-calc and stuff like that. Synthetic substitution. Okay, so let me give you guys one to try. This will be the last thing, so try that guy. Okay, so let's get this set up again. In this case, you do not switch the 2. When you're finding synthetic, values of a function, you just plug in exactly what it is. Okay, so I'm going to use 2, and then I'm going to use my coefficients of 4x to the 4th, negative 1x cubes, negative 19x squareds, 11x's, and negative 2 constants. All right, and then we got the process. Hopefully you guys work this out. Bring your 4 down and multiply. All right, negative 1 plus 8, 7, multiply by 2, 14, add, negative 5, multiply by 2. Okay. All right, so we got a 0 here. Okay, so what we just found, g of 2 actually equals 0. Okay, this is not like, it's not exactly the same as saying something's a factor. I mean, it's all related, but for now, we're just saying what we literally just found was that g of 2 equals 0. Okay, so the question are, what does that mean? Okay. Okay, what does it mean about the graph? Where? When x is what? When x is 2. Okay, so this is saying a couple things. It's saying 2 is a 0. Remember on your calculators? Either a 0 or sometimes we call it a root. 2 is one of those things. If we were to graph this thing, it would go through 2, 0. That's what we just found. So 2 is a root of that function g of x. I don't want to rewrite the whole thing. It's just, we'll call it g of x. So 2 is a root. All right, and then kind of where we're going tomorrow and the next couple days, what would be a factor? If 2 is a 0 or a root, what would one of the factors have to be? Something about 2. What would go in here? X what? Minus 2. Because remember, when you solve it, this would give us positive 2 as a root. The factor is x minus 2. Again, that's where we're going tomorrow. So don't, sweat that yet. What you guys need to know today is just how to do this process up here. Okay, and I'm just kind of leading into where we're going. Okay. And what that's going to do, it's going to help us solve these things. Like if we can do this process and get one of the zeros, we can use that to find some of the other ones. Okay. Yeah, when x is 2, yep. So this is like an x, right? And that's like the y. So this graph would go through, like one of the zeros would be right here, and it would do whatever it does, but it would go through there, okay? Okay, and it probably wouldn't look like that because I think the end behavior would be different, but okay. Okay, so for some practice, assignment is there. Okay, I gave some of the odd problems so you guys can check your work. Okay, so make sure you show me the steps. I want to see the synthetic process, but feel free to check your answers in the back.